Earlier in the course, we looked at how LTIC systems can be represented in the time domain, where LTIC stood for a linear, time-invariant, continuous time. Now we want to look at how LTID systems can be represented in the time domain, where L still stands for linear, TI stands for time-invariant, and D stands for discrete time. Similar to continuous time systems, LTID systems can be described by their input-output equation. But instead of containing the output signal and its first n derivatives and the input signal and its first m derivatives, it now contains the output signal y at time k up until time k plus 1 and the input signal x at time k up until time k plus m. For LTIC systems, we saw that if m was greater than n, the system was improper and hence unstable. This is not the case for LTID systems. However, if m is greater than n, then k plus m is also greater than k plus n, which implies that the output value at time k plus n depends on the future input value x at time k plus m. Hence, if m is greater than n, the system is non-causal. As for LTIC systems, the coefficients ai and bi of the input-output equation of LTID systems are constants. Since LTIC systems can be accurately described by their impulse response h of t, it's not surprising that LTID systems can also be described by their impulse response. But this time it's given in discrete time, so we denote it as h of k. It can be obtained as the output of this system when applying an impulse signal as an input, which is somewhat easier in discrete time since the discrete impulse signal is simply equal to 1 for time k equals 0 and 0 for all other times k. Then the output signal y of k can be received for any input signal x of k, as the output signal y of k is equal to the convolution of the input signal x of k and the impulse response h of k. The convolution is now a convolution sum for m equals minus infinity to infinity of x of m times h of k minus m. The properties of the convolution sum are very similar to the properties of the convolution integral, and you can find more information about this in the script.